image of mod z minus 3i equals 3 under the transformation w equals 1 by z. We have w equals u plus iv and z equals x plus iy. Therefore, this transformation can be written as u plus iv equals 1 by x plus iy, which can also be written as x plus iy equals 1 by u plus iv. If we multiply numerator and denominator with conjugate of u plus iv, we have x plus iy equals u minus iv upon u square plus b square. When we equate real and imaginary parts, we have x equals u by u square plus v square and y equals negative v by u square plus v square. When we simplify mod z minus 3i equals 3, we have z equals x plus iy. Therefore, we obtain x plus iy minus 3i inside the modulus. Here, when we group real and imaginary parts, we obtain modulus of x plus I times y minus 3 equals 3. We know that modulus of a complex number is square root of sum of squares of real and imaginary parts, because we have studied modulus of a plus ib equals root of a square plus b square. Therefore, here this modulus can be replaced by the expression square root of sum of squares of real part x and imaginary part y minus 3. We obtain RHS as 3 itself. Now, when we square both sides, we are free of the square root sign in the LHS and our RHS become 3 square, which equals 9. When we expand y minus 3 the whole square using the formula of a minus b the whole square, we have y square minus 6y plus 9, and since 9 is common to both LHS and RHS, it can be cancelled, and we have the simplified expression in the xy plane obtained as x square plus y square minus 6y equals 0. We are looking for the corresponding image in the UV plane. Therefore, we will replace x and y using these expressions, and we get this expression, which is the equivalent image of this equation in the UV plane. Observe that these two terms are having common denominators and hence they can be grouped. When the first two terms are grouped, we have u square plus v square upon u square plus v square the whole square plus 6v upon u square plus v square. Here, numerator and denominator have u square plus v square common and it can be cancelled. Therefore, we are left out with u square plus v square in the denominator. Now, these two terms can be grouped because they have common denominators. We have 1 plus 6v upon u square plus v square equals 0. When we multiply u square plus v square along with 0 in the RHS, we have 1 plus 6v equals 0, which is of the form ax plus by plus c equals 0, which is the general equation of a straight line lying in the xy plane. Here, since we obtained 1 plus 6v plus 0u equals 0, this represents equation of a straight line in the uv plane or the w plane, which is the desired image of the equation mod z minus 3i equals 3 under the transformation w equals 1 by z.